Okay, now so we've taken a look at writing and balancing equations, and we'll get an opportunity to review a little bit of that as well. But now what I want to talk about is types of chemical reactions. So types of chemical reactions, which in turn we are going to define as types of chemical equations. The first is direct combination or synthesis. Depending on who you ask, they may describe it different ways. Direct combination, synthesis reaction. It's one of the very simpler. It's one of the simplest types of reactions. And basically, if I describe it as this, I think I can define it and then also give some examples. I think it'll be pretty simple to understand. But basically, it's when two or more reactants get together to produce only one product. So two or more reactants getting together to produce only one product. I like a generic little analogy here. Notice, let me see if I can grab a color that we can see on this gray board. A plus B yields AB. So two or more reactants producing only one product. A very simple example would be hydrogen getting together with oxygen, and again, that could be the word equation. Hydrogen gets together with oxygen to produce or yielding water. Okay, so hydrogen reacts with oxygen to produce water. A quick reminder that hydrogen is diatomic. Whenever it's alone, it's never alone, so that's why we have the 2 here. Oxygen also is diatomic, O2. Notice that when oxygen and hydrogen get together, they're no longer alone, so we can have one oxygen. So obviously water is H2O, so we write the correct formula. It's not balanced yet. Let's go ahead and balance it. 2 hydrogens on this side, 2 hydrogens on this side, we're okay. 2 oxygens. I need to put a 2 in front of the water to make sure that we have the 2 oxygens, which changes my hydrogens now to 4, so I need to come back over here and put 4. This is a direct combination reaction. It's as simple as saying 2 or more produce only one product. Okay, we can have more than 2, and I'll show examples later on, but that's a simple direct combination reactant. The second type is a decomposition reaction. Decomposition, basically the opposite. A decomposition reaction is when one reactant breaks down into 2 or more products. So the generic formula, as you can see here, A, B breaking down into A plus B. Obviously, water can break down into H2 and O2. Of course, if I were to balance it, this is what we would be looking at. This would be a decomposition reaction. So again, direct combination or synthesis is when we have only one product. That's the key here. A decomposition is when we have one reactant. So those are those 2 types. Moving right along here, and I think it's easy enough and simple enough that we can move right to the next type. I only have 5 that I'm going to describe, and certainly there are exceptions, but the third type is the single replacement reaction. Single replacement reaction is when one, and again the description here I have may not be as easy as when I show examples, but when one reactant is alone, so it's a singular element, or it could be diatomic, but one reactant is alone and it replaces one of the other reactants, which is a compound's atom or ion. And again, not probably the best description, but let's take a look at the generic. You can see it up on the top right near where it says Smart Ink. We have A plus BX forms B plus AX. Okay, so this would be a single replacement reaction. Let's go ahead and take a look at an example, and I think that's probably the best way of doing it. Let's say we have zinc reacts with, HCl, hydrochloric acid. Okay, so zinc and hydrochloric acid, very common reaction. In fact, I showed it earlier in this unit where you just put some zinc with hydrochloric acid, you're going to get this bubbling and fizzing. Well, you can know that this bubbling and fizzing is going to happen because of the single replacement reaction that's happening. So notice that the zinc is alone and that H and Cl are together. Now, which one is the zinc going to replace? Well, you should be able to determine which one zinc is going to replace by looking at what its charge is when it forms an ion. Because zinc is a positive charged ion, a cation, then it's going to want to get together with the Cl. So ZnCl2. In this case, we're looking at zinc 2. So ZnCl2. And then notice now the H is alone. But I remind you that whenever H is alone, it's never alone, so H2. All right? So this is a single replacement reaction. We have something that's singular, alone, getting together with a compound. Notice this compound, HCl. And we should be able to determine what the product is by looking at what the compounds are. Okay? Now this one's obviously not balanced. I would need to put a 2 there. But there's a single replacement reaction. And I'll show more examples as I go through the examples later on. Okay? Let's see here. Yeah, we've got time to do the next one. And we'll do the next two. The next one is a double replacement reaction. Double replacement reaction is where both reactants are compounds and they swap cations and anions. So a very simple example of this one, well, let me first show the generic. But notice A is with X and B is with Y, and then they swap. So notice we always put our positive, our cation first, negative second, positive first, negative second. Notice that the A is positive. It will get together with the negative, the A with the Y, and the B, which is positive, will get together with the X, and notice your BX. So that's the generic formula. Let me give you an example. How about we have NaNO3, sodium nitrate, getting together with, how about aluminum sulfate. Okay, aluminum sulfate. Quick reminder that you should know that aluminum sulfate formula is Al2SO43 because, and I'll just off to the side here, aluminum is a 3+, sulfate's a 2-. We've got our 3+, our 2-, our least common is 6. We need 2 aluminums and we need 3 sulfates. Same thing with Na. Na is a plus, NO3 is a minus, so you need 1 of each. Okay? Now, this is going to double replace. Now, how do we know it's a double replacement? Because we have a compound, positive and negative, with another positive and negative. So, we're just going to simply have that replacement. I'll keep it in yellow here, I guess. The sodium, which one do you think the sodium will want to get together with? Well, because it's a positive, it will want to get together with the sulfate. So, Na will get together with SO4. We need to write the correct formula for that when it gets together. Now, I know that on the reactant side we only have 1 sodium, but we need to have 2 on this side because sodium's a +1, and when it gets together with sulfate, which is a 2-, we need 2 sodiums. And the other reactant, the other product is going to be the aluminum getting together with the nitrate, which should be AlNO3 3. Again, that's because we have a 3+ getting together with a 1-. So there's our formula, or our equation, I should say. The sodium nitrate getting together with aluminum sulfate to produce sodium sulfate and aluminum nitrate. Now it's not balanced, but that is your double replacement reaction. Let's go ahead and balance it real quickly. 1 sodium, 2 sodiums. We better put a 2 in front of that. I'll go to my aluminums next. 2 aluminums. 1 aluminum. Let's put a 2 in front of that one. I'm going to save my O's for last because they're in everything. I'll go to my N's. Here I have 2 N's. Here I have 3 times 2 more is 6 N's on the product side. So I better change this 2 over here to a 6. My tips, I just changed my sodium, which was okay. I better change that right away. So I put a 3 on the other side to have 6 on both sides. Now look at my sulfurs. I have 3. Here I have 3. And my oxygens, I better okay. I've got 18, and another 12 is 30. Here's 12, and another 9 times 2 is 18, and my oxygens are okay. There's a double replacement reaction.